So they will only accept this box if the sum of the length and the girth, so that's like perimeter, does not exceed 108. So 108 is the maximum. So if you have something that's like a box, which I happen to have one right here, there's a box and I need to send that through the mail, then they're going to measure the length and then they're going to measure around it. And in total, that cannot exceed 108. On this one, the box has a square end. So here's one end of it, and it's a square, it's x by x. And then it would go back and have a length. And I don't know what that length is, but we'll call it y. Then we're supposed to maximize the volume. Well, when you have a rectangular box, its volume is just one side times the other side times the other side. So the volume is equal to x times x, so that's x squared, times y. That's the main equation. The other equation is going to use this 108, which is saying if you find the perimeter, so going around the edges of the box, that would be an x plus another x plus another x, plus its length. At the very most, that could equal 108. Then for this auxiliary equation over here, we could solve for y. It's going to be 108 minus 4x. Now take this and substitute in for that y value right there. So our new formula for the volume is it's x squared times 108 minus 4x. And of course, we're going to take the derivative and do algebra and such, but I just want to make sure that this is a function that's even possible before I do the work of taking the derivative. So we want to make sure that it's as large as possible. So this function should have a maximum. X squared times 108 minus 4x. Then what about the window? So don't really need any negative. X is, so it could be 10 inches. I'll bet it could be even bigger than that. I'm going to try 20. And then this would be the volume, and don't need any negative volume. And then if it was 20 times 20 times 20, because they're talking about the volume, so it could be 8,000 cubic inches. That should be enough to see the graph. Let's see. Oh, it just keeps going. Where did it go? It's going up to the 11,000s, and then it's coming back down. Now it's back to 9,000. So they're actually willing to take boxes much bigger than I thought. What did it go up to? Oh yeah, you're right, 11,000. So let me put 12,000. But then again, this is in inches, so it's not like it's cubic feet. Oh yes. So it seems there is a maximum right there. So I believe this is set up correctly now. First thing I'm going to do is distribute the x squared. So there would be a 108x squared and then minus 4x cubed. Next, take the derivative. So that will be, take the 2 down in front and multiply. So that's going to be 216x minus 12x squared. And then we could factor. So I know that we could factor out an x. What about with a 216, can you factor out a 12? Yes, it goes 18 times. So we could actually factor out a 12x. This, when I just divided it, that's 18. and then minus, I factored out the 12 and I factored out one of the x's. So this would give us the answer x equals 0, which means that the box does not exist. And this would give us the answer that x equals 18 inches. So we're going with this answer, x equals 18 inches. Then we need to find out what y equals. So substitute the 18 over here, and y is going to be a 108 minus 4 times 18. 108 minus 4 times 18. So it could be 3 feet long, 36 inches. So then x is equal to 18 inches and y is equal to 36 inches.